Hi, my name is Youngjae Kim and this is my first video assignment about engineering mathematics, and I will show you to solve the problem about the Laplace transform. Alright, let's take a look at the number 25 of problem set 6.3. Here we have a second ODE, y double prime plus y would be equal to 2 times t when time t is greater than 0 and less than 1. And also the right hand side of the equation would be 2 when time t is greater than 1. But we don't have any initial conditions, so we assume that let y of 0 would be equal to a and y prime of 0 would be equal to b. Alright, so in order to solve the second order ODE, we need to perform the Laplace transform. So first step 1 is find the Laplace transform of the left hand side of the equation, y double prime plus y would be equal s squared times capital Y minus s times y of 0 and minus y prime of 0 plus just capital Y. Alright, so the right hand side of the equation, the 2 or 2 times t, and depends on the time. Alright, so you could change the right hand side of the equation with using the unit step function, and you can express like that 2 times t of 1 minus u over t minus 1 and plus 2 times u over t minus 1. Alright, and you can more simplify this equation, 2 times t minus 2 times t minus 1 times u over t minus 1. Alright, and you can Laplace this equation. Alright, so you can 2 over s squared minus 2 times exponential to the minus s over s squared. Alright, so we will find the Laplace transform of the order of equation. So you can express like that. So s squared times capital Y minus a times s minus b plus capital Y would be equal 2 over s squared minus 2 times exponential to the minus s over s squared. Alright, so you can tied up these two, capital Y of s squared plus 1 would be equal a times s plus b plus 2 over s squared minus 2 times exponential to the minus s over s squared. Alright, so you find the subunitary equation, and this is a transfer function. So you can figure out y of s would be equal a times s over s squared plus 1 plus b over s squared plus 1 and plus 2 over s squared times s squared plus 1 minus 2 times exponential to the minus s over s squared times s squared plus 1. Alright, so this is more simplified than these two equations. So we got some mathematical method using the partial fraction decomposition. Alright, so this is 1 2 over s squared times s squared plus 1. You can break down a over s squared plus b over s squared plus 1. How can you find a? The multiplied s squared, or the order of this equation, and put the s to be equal to 0, and you can simplify it. Simplifying the a would be equal to 2, and if you multiply these two equations, a times s squared plus a plus p times s squared would be equal to 2. So the a would be equal to 2, so b would be minus 2. Alright? Yeah, we all find the y of s, so we can express the y of s would be a times s over s squared plus 1 plus b over s squared plus 1 and plus 2 over s squared minus 2 over s squared plus 1 and minus of 2 over s square minus 2 over s square plus 1 times exponential to the minus s. Alright? So we will find the algebraic equation this function. Alright? So we were gonna do the inverse Laplace transform of this capital Y of s. So this is the y of t. That is what we want to find. Alright? So the inverse Laplace transform y of t to be equal a times cosine of t plus b times sine of t and plus 2 times t minus 2 times cosine of sine of t and minus 2 times t minus 1 because of the unit step function. Alright? So times u over t minus 1, alright, and plus 2 times sine t minus 1, and times u over t minus 1. Yeah, we'll find the y over t, and you can more express y over t about range. You can express a times cosine t plus b times sine t plus 2 times t minus 2 times sine of t when the t is less than 1 and greater than 0. Alright? And also you can express a times cosine t plus b times sine t and plus 2 and minus 2 times sine of t and plus 2 times sine of t minus 1 when the time t is greater than 1. We will find all of the yt. Alright, thank you.